2 is going to go over how to graph a linear equation. There are a couple different ways that you can graph a linear equation. That's all going to depend on what the original format is. For example 1, this equation is in slope-intercept form, which means it's in y equals mx plus b format. To graph, we're going to identify the term that is in the b position, and then use whatever we have as the m to plot our next point. So b is going to be what's added on or subtracted from the end of the equation, and in this particular problem, my b is -4. And that means for my very first dot, I'm going to start down at -4 on the y-axis. Next, I want to look at the slope. The slope for this particular equation is 5/3. Slope is rise over run, so that means that I am going to be going up 5 and to the right 3 from this -4 starting dot. So from this -4, I'm going to be going up 1, 2, 3, 4, 5, and then to the right 1, 2, 3. Notice that I don't put a dot until I actually do both of those steps. The last thing then to do is simply connect your dots into a line. So graphing, whenever you have the y-intercept or the slope-intercept form, the y equals mx plus b, doesn't really involve as many steps as if you don't have it in this format, which is what we're going to look at next. So for example 2, I have x plus 2y is equal to 10. This is not in slope-intercept form, but I am going to put it in slope-intercept form by isolating the y. So our first step in isolating the y is going to be to subtract the x. That leaves me with 2y equals -x plus 10. And then to get the y by itself, we're going to divide by 2. So my final form of my equation is y equals -1/2 x. Remember, there's this -1 on top with x, so that's going to stay as a fraction, -1/2. -1/2 x, and then plus 5, because 10 divided by 2 is 5. Notice when I divided by the 2, I did divide every term in the equation by the 2. It is important that you do that. Now my equation is in slope-intercept form, so I can identify my b, which is 5. So I'm going to start up at 5 on the y-axis. Again, b is always graphed on the y-axis because it is the y-intercept. M is -1/2. That means we are going to be going down 1 and to the right 2 from that starting spot of 5. So from this dot, I'm going down 1 and over 2, and then I put another dot. If you're drawing this freehand, you can do that same process again. You could go down another 1 and over another 2. Sometimes it's easier to get your line drawn whenever you have more than one dot to connect. And that's graphing if you have an equation that is not in slope-intercept form. Now, there are a couple other special scenarios that happen with equations where you might not have both letters when you have to graph. And that's what we have here in example 3. So in example 3, we are going to be graphing these equations. Our first equation for part A is just an x, and the second part is going to have just a y. So we have an x and we have a y. So for part A, we have x equals -1. That means you're going to go to -1 on the x-axis. And I'm actually going to put a dot there. Now it's important to think about where all the x values are that are -1. Those are the points -1, 0, which is the dot that I graphed, -1, 1, -1, 2, -1, 3, and all of those dots are going up in a vertical line. You can also have -1, -1, -1, -2, -1, -3, all the ones going down. So if we connect those dots, and I'm sorry that my line isn't exactly the straightest there, you actually have a vertical line. Anytime you have an X line like this, when you graph, your line will be vertical. For letter B, we have a Y line. Y equals -4. So again, I'm going to go to -4, but this time I'm going to go on the y-axis because I have a y is equal to -4. So you're thinking now about all the points that have a y value of -4. That would be things like 0, -4, which we just graphed, 1, -4, which would be right beside it, 2, -4, which would be beside that, or the other direction, -1, -4, or -2, -4, and all the other dots beside that. If we connect these, you can see those connect in a horizontal line. So if you have y equals a number, those lines are going to be horizontal. So to refresh, x lines are vertical, y lines are horizontal, if it's y equals a number. The last thing we're going to look at today is graphing using intercepts. So in order to graph this one, we are going to find both the x and the y intercept. This is useful if you're struggling with putting an equation into slope-intercept form to graph, but it's not always the best way because occasionally when you solve these, you're going to get fractions for your x and y intercept, and it's not always the easiest to be accurate whenever you're graphing a fraction. So the first thing that we're going to look at is an x-intercept. And an x-intercept happens when y is equal to 0. So to find the x-intercept from this equation, x plus 3y is equal to -3, we are going to replace the y in that equation with a 0. So I have x plus 3 times 0 is equal to -3. Well, 3 times 0 is just 0, so that piece is gone. And that leaves me with x equals -3. That is an x-intercept, so it is on the x-axis. So I'm going to go over to -3 and put my first dot. Now to find the y-intercept, I'm going to let the x be 0. So whatever intercept you're trying to find, you let the opposite letter be 0. So now my equation is going to be 0 plus 3y is equal to -3. And I need to solve for the y. The 0 plus 3y is still 3y. It's almost like the 0 just drops out of the equation. So I have 3y equals -3. I would divide both sides by a +3, and we get y equals -1. So this is our y-intercept. It's on the y-axis, so I'm going to go down to -1 and put a dot. And then all you have to do is connect your two dots to make your line. This, again, is useful whenever your intercepts are integers. It's not always going to be the best way, especially if you end up with fractions in your answers. So I hope that this was useful and to help you graph some lines. And as I always say, please contact me if you have any questions.